Good morning, students. In last class, we have observed that what is the meant by fuse wire, what are the advantages, what are the disadvantages. I think fuse is a protective device. Fuse is also a current interrupting device, but it has the drawback. After each operation, we have to replace new fuse wire. It is one of the main drawback. Yes, sir. The same function of the fuse wire is obtained from a modified fuse we can call, that is known as miniature circuit breaker. In short form we shall refer as a MCB. Now you can observe as per the single line diagram of simple wiring exercise. So first we receive the supply through the service lines, that is from pole to house. Those are referred as service lines. Once these lines are comes to the house, then first it goes to the meter board, which is mainly consist energy meter. Now you can observe there is a phase wire, there is a neutral wire, hence two input terminals are there for energy meter. Then there are two output terminals also there. From two output terminals we are going to supply in series. One block diagram is there, MCB, that is miniature circuit breaker. Then you can see there it is double pole double through device. Now you can see there double pole double through device. It may be single pole single through, or it may be triple pole triple through. Now it is double pole double through, hence it has a operating switch. Blue colored part you can see, that should be operating switch. It is may be kept in off position, it may be kept in on position. Then again it is connected to another circuit breaker, ELCB. Every advanced building has these two very important. ELCB, earth leakage circuit breaker. If any leakage happens, then this circuit breaker trips. Then after this is also double pole double through switch. It is similar to that type of structure, MCB. Hence from MCB output is given input to ELCB breaker. Then output of this ELCB is taken for further connections, that is different type of house connections. So it is main MCB because if any fault occurs, this circuit breaker trips. So each room may consist different circuit breakers, MCBs. Then those are referred for sub MCBs. Sir, earth connection is also required. We have to give the equipment earth protection from meter board. The diagram shows cross-sectional view of MCB. It mainly consists incoming terminal, outgoing terminal, and knob, solenoid, latch point, bimetal strip, and arc extinguishing chamber as shown in diagram. These two diagrams shows very clearly when the MCB is on state. You see there lever position is contact with the bimetal strip, then outgoing terminal, incoming terminal is contact with fixed contact and movable contacts as shown in number 1 diagram. Number 2 diagram, it is off position. When the knob, operating knob is in below position, that is known as off position. Here the lever position is disconnected from the solenoid point, and movable contact is separated by the fixed contact, that is off state. Here the diagram shows the working principle of MCB. The MCB may be operated by two conditions. Either it is thermal circuit, either it is magnetic circuit, or some designs having operation of both, that is thermal, bimetal element and magnetic circuit as shown in figures. Number 1, as per the thermal effect, so bimetal element is subjected to flow of normal current if the normal current means less than specified value of circuit breaker. Hence there is no temperature rise in the bimetal element. The current flows through the magnetic element, then it is connected to latch, then moving contact and fixed contacts are contacted. Hence the current flows through the electric circuit through the MCB in this manner. This is normal condition. The second condition we can see there, when the current through the bimetal strip increases, the temperature rises. As the temperature rises, a thermal expansion takes place. In the figure number 2, as the thermal expansion takes place, it catches the latch point. It catches the latch point. Hence this movable contact is open from the fixed contact. The circuit becomes off. It happens when the abnormal current flows. The thermal expansion of bimetal takes place. This is the one method. And second method, under the normal working condition, the slug is held in a position by light spring. So this operation is due to magnetic field. The magnetic field developed due to the flow of current is not sufficient to attract the latch. This happens during normal condition. When the fault current flows, the fault current or short circuit current flows, it is more higher than normal current. When the fault current flows through the magnetic coil, the magnetic field developed, which is sufficient to overcome the spring force holding the slug. That means it attracts the slug, then which results the tripping of mechanism. So during the short circuit condition or fault condition, this operation is mainly carried by the magnetic coil development. Hence both are designed, either bimetal strip action as well as magnetic field developed. Both happens in circuit breakers. You understand, please, sir? The working principle of MCB. Under normal conditions, MCB operates as a switch. It is operated in manual mode. It may be kept in on condition or it may be kept in off condition. Whenever overload occurs or short circuit condition occurs, the operation is automatically. When the switch is kept on, the current is flowing through the load circuit. When the load circuit expects, or when load circuit is happens with a short circuit or a fault current, this high current flows through the MCB, then MCB trips. MCB trips as per the time delay. Hence the current is interrupted from the load circuit. Hence this second operation is automatically. Hence once the fault is happens, it is tripped. Again we have to make the switch on position of the circuit breaker. Hence we have to clear the fault. We have to check the circuit once again. The fault should be cleared. Then we have to make manually on position. If the fault is completely cleared, then it remains on position. If fault is still there, then again it becomes off. This is the main operation of MCB. The MCB may be operated at two conditions. Either it is bimetal strip, either it is development of magnetic circuit. Already it has been explained. Once again, when the bimetal strip subjected to normal current, it is not going to bend. It remains straight. When the current through the bimetal strip extends above the rated value or abnormal current flows, hence its heating effect rises. Hence it is due to thermal expansion bented one side. Hence the moving contact may be opened by the latch action. So second one, development of magnetic circuit. So magnetic field, it is not possible to force the spring action. Magnetic field is weaker when the normal current develops. When the short circuit current flows or fault current flows, the magnetic field developed is sufficient over the spring action. Hence, it also opens the moving point from the fixed point. Hence, both are designed in MCB. A combination of both magnetic field and thermal tripping mechanisms are implemented in MCB designs, both magnetic and thermal operations. So both operations are useful. By making the such operations, a huge amount of arc is formed between the contacts, between, that is, fixed contact and moving contact. When the fixed contact is one terminal, moving contact is another terminal. By opening of moving contact, it is separated by huge amount of arc. When the arc is developed, this arc should be controlled by the arc chutes or arc runners. Hence, it provides the suitable amount of high resistance. The arc is extinguished and arc is cooling effect. This is known as arc chute chamber. Arc should be suppressed. That is the idea. When the large current is interrupted, means huge amount of arc develops by the separation of contacts, fixed contact and moving contact. This arc should be controlled by different methods are there. Hence, we have to required arc chute and arc forces. Arcs should be spread out. After some time, this arc should come to control. This process is known as arc extinction method. Now you can view the diagram. There are three different types of the circuit breakers. Number one, you can see always these circuit breakers or MCBs are connected in series. Series part of the electrical circuit, as we observed how the fuse is connected in series, same points. So you can see there single pole, single through switch, diagram number 1. Then diagram number 2, double pole, double through switch, double pole, double through switch. Diagram number 3, triple pole, triple through switch. You can observe, depending upon the circuit breakers, which type you want. Either you may give the protection for in only one line, that is single phase, single pole, single through, or you want to give in 2 lines, then we can use. Either you can go for 3 lines, we can use third one, and so on, as shown in diagram. Now you can see there what is the difference between MCB and fuse. So first of all, MCB trips off in the case of excessive load, short circuit or fault current. What about the fuse? Fuse melts and it blows out during the short circuit or excessive load condition. Number 2, MCB is just put on after they correcting the fault, but fuse, it is not having such a facility. Fuse, we have to replace next new wire before start of the connection. MCB is a little bit costly. MCB consists some relay unit and it may be operation different in advanced. Hence, the MCB is costly, but fuse is less costly. It is a simple device, just wire we can call. It is having a less cost. So MCB is compact and it is small equipment. Fuse wire is placed on porcelain base and it is not attractive. The MCB working based on bimetal expansion or induced magnetism. So fuse depends upon melting. Fuse wire goes on melting. So last one, MCB has high reliability, fuse has less reliability. Hence, MCB are more useful in distribution electrical networks. Fuse also used where the reliability consideration as secondary. Thank you to one and all.